Okay, I was going to talk about the general firing procedure. I guess we're doing okay on time. I guess I'll go through that. I didn't know whether we'd have a lot of questions or not, but this is just sort of a general firing procedure that I follow. First of all, safety. If I start a firing and I light the burners, if the flame goes out, don't relight the burners right away. If the burners don't relight by themselves, because especially with propane, if I've got a mixture of gas and air in there, I've got a bomb. And this is about the only time when you've got a potential hazard with gas is early in the firing, before the kiln gets hot. If I blow gas in there and I get a gas-air mixture, I've got a bomb if I try to relight it. So if that happens, what you have to do is open the kiln and let it air out, let it sit. And in some cases, I might pull the bricks out. I might pull some bricks out if it's a brick kiln, or I might open and let it completely air out so that I don't smell gas in there anymore before I try to relight it. Once the kiln gets to the point where the bricks are glowing or the kiln is hot, it will relight, and that's not a problem. So the explosions, the potential explosions of the gas kiln are only very early in the firing before the kiln itself has gotten up to several hundred degrees. Once it gets hot to the point where the bricks are incandescent or things are glowing, it will relight it almost immediately if the flame were to blow out, for example, or snuff out. So it's only very early in the firing. So normally for firing, and if I'm firing bisqueware, I'll do a slow initial heat up, really just to make sure that the pots are dry, especially let's say I'm firing somebody else's work I'm not sure how long ago they glazed the work. I'll do a slow heat up, and I'm heating the pots, I'm heating the kiln, and I'm also heating up the chimney, because the chimney won't draw until it gets warm. So I do a slow initial heat up using a lot of air. I have a lot of air going at this point because I'm just trying to get heat. I'm not worried about reduction at all. In most cases, a long candling is not necessary. You don't need it. It's a waste of heat. So all I'm trying to do is especially with bisqueware, all I'm trying to do is basically get the kiln, the bricks heat, and really just get the chimney to start to draw. So then I'll increase the heating rate to about cone 012 typically. I found 012 is good for most glazes, 012 to 011, and that's when I go into reduction. And this is the stage that's typically referred to as body reduction. And what this really means is, long before the glazes melt, I'm assuming this is, you're firing in gas and you're doing this for reduction. Long before the glazes melt, you have to go into reduction to allow the gases to penetrate into the powdery. The glaze now at this stage is just a layer of powder on the surface of the pots, right? So I have to go into reduction to allow the gases to penetrate into the powdery glaze layer to reduce the glaze, and actually go through that and penetrate into the clay to reduce the clay. And if I wait too long, if I wait and when the glazes start to melt, I don't get reduction because the gases can't penetrate into the glaze. So I have to do it early enough before anything in the glaze starts to melt so that the gases can penetrate. And by the way, with reduction, what's doing the reduction in the kiln is carbon monoxide, not soot. So if you're firing a gas kiln and you're making a lot of soot, you're wasting a lot of fuel and you're not even getting good reduction. You want to make carbon monoxide, CO, not soot. And if I have carbon, like I mentioned, if I have like the methane, let's say I'm burning natural gas and I have CH4, when I'm burning that, the carbon is reacting with the oxygen, and the first thing it does is I can make carbon monoxide or I can make carbon dioxide. If I start to break this down and I don't even have enough air, all I make is carbon, soot, like you get from a candle. The soot you get from a candle where you don't have enough air to burn it. And so soot it's the carbon monoxide that's doing all the reduction in the kiln. So I don't want to make soot. If I'm producing a lot of soot, I don't have enough air. Okay? So it's the carbon monoxide that I actually want to penetrate into that layer of powdered glaze and down into and at least contact the surface of the clay. Remember, at this point, if I'm doing, well, it doesn't matter whether it's bisque or raw, the clay is porous also, right? So the gas can actually get into the clay. It can go into the glaze and into the clay and react with the clay and the glaze and produce the chemical changes that give me the colors I want. And if I wait too long before the clay starts getting dense or the glaze starts melting, I won't get good reduction. I won't get good color because the carbon monoxide can't penetrate into those materials. So, and some glazes, you need to get really early reduction and really heavy reduction. And so, I mean, again, it depends on the glaze, but I found like around 012 is when I usually start, which sounds pretty early, but that's when I usually start going into reduction. Because then, especially if you're doing what glaze is called copper reds, you need to do very heavy early reduction. And if you wait too long, the glaze is already starting to melt and there isn't enough time for the copper to change to the form that will give you the color you want. So if I want to go into reduction, basically I'll close the damper a little bit. Let's say I'm working with a Venturi burner. I'll close the damper a little bit. That'll cut down the secondary air that's being pulled into the kiln. So if I cut down the secondary air, now I don't have enough air to completely burn all the gas, and I produce reducing conditions in the kiln. But what I also want to keep in mind is when I go into reduction, if I'm burning less gas, I don't want the temperature to drop, or ideally I don't want it to sort of stop rising. So the trick is to learn with the damper. How much damper how do I work the damper so that I go into reduction, but I'm still burning enough so that the temperature is still going up? The balance between reduction and still burning enough gas to keep the temperature rising, that's the trick to operating it. And one of the things you'll see with a gas kiln when you go into reduction is you'll see flames that start to come out, the peepholes or the spy holes or things like that. Then you hear people say that's because the flame is looking for oxygen. That's baloney. It's not looking for oxygen. The answer is, I'm blowing, now this is a gas kiln, I'm forcing gas into the kiln because of the pressure. I'm blowing gas in there. The gas has to go out somewhere. Well, I've just blocked the exit. I haven't cut down the gas. I'm still blowing gas into the kiln, but I've closed the door a little bit, the exit door. Well, that gas has to come out somewhere, so now it backs out all these little holes and cracks and things. And yes, it looks yellow because it's yellow just like a candle flame because it's not getting enough air to burn completely. But it's not coming out because it's looking for oxygen. We're anthropomorphizing the gas. It's just, I'm forcing the gas out because of the back pressure. But but when it's doing that, that's when I know I've created the back pressure, which is what I want. I've choked the kiln a little bit and I'm not drawing in as much air. Because if I was drawing in air, the air would be going in the peepholes. I'd be sucking in air. Well, this says I'm not. I've created this back pressure by closing the damper so that now there's a good chance I'm going into reduction. And the other indication to look for is you'll start to see a hazy atmosphere in the kiln. If you're burning in oxidation, because you're getting little carbon particles actually in there, and you'll if you look inside the kiln, instead of being crystal clear, where normally you could see the pots and especially you could see your cones, now all of a sudden it becomes so hazy you can't see anything. But that's another sign of the reduction is you get this hazy atmosphere. So anyway, I might, depending on the size of the kiln and the glazes I have there, I might leave it in reduction for half an hour or maybe an hour. I'm still going up in temperature slowly, not as fast as I was before, but I stay in reduction, and now I'm allowing this time for the carbon monoxide to react with the glazes and do the color changes that I want. Because if you think about it, the only reason to fire in reduction is color. That's the only reason we do it, to get certain chemical reactions with the glazes and the clays to give us certain colors. Otherwise, there's no advantage, no reason to do it. So I'll stay in reduction for maybe half an hour, depending on the size of the kiln and the glazes. And as I mentioned, while I'm doing that, I'm balancing the reduction with the heat rise. I'm trying to keep enough reduction in there so that I'm affecting the glazes, but I don't want to stall the kiln out or have it even worse, have the temperature start to go down because I've choked it too much. So I'm playing with the controls a little bit to maintain that balance. And finally, after the hour is up, let's say, then I say, okay, I don't need as heavy reduction anymore. I'll go to a little lighter reduction. I'm still in reduction, but I'll get it to where I can increase the temperature faster. Because if I decrease the amount of reduction so that the reduction is not as heavy, Now I'm burning the fuel more efficiently again, so I'm getting more heat out of it, so my temperature can go up faster. So now I'm headed toward the end of the firing. I still want to keep it in reduction. I don't want to undo everything I did earlier. But now I can take it up faster toward the end of the firing. And then I start watching the cones, to see what happens. And then at the end of the firing, with gas firing at least, there are several different options I have as far as how do I end the firing. Well, one thing I can do is I can just shut the kiln off. When the right cones go down, I can just say, I'm done, turn the kiln off. I could also, I could go into a hold. If I have a kiln where my temperatures are not even in different parts of the kiln, I could say, okay, I'm going to hold it for a while, not try to increase the temperature, just maintain the temperature to allow my temperatures to even out a little bit. I can do that. I could also do a clearing, which means now I purposely go out of reduction at the end and make it into more of an oxidizing atmosphere to brighten up some of the glazes. Some glazes respond to this. They get a little brighter if you clear the kiln at the end. Maybe you've made too much soot during the firing and your glazes have gotten a little dull. And so it's called clearing the kiln. I can actually clear the kiln and brighten the glazes sometimes by doing a little bit of oxidation at the end of the firing. And now I'm not going to reverse all my effects because the clay is solid, the glazes are solid, so the gas really can't penetrate into the glazes or into the clay. All it can do is affect the surface. So in some cases, it'll brighten the colors by going to oxidation at the end. Some people also do what they call cycling at the end of the firing. They'll go reduction and go oxidation for a little bit, and then back to reduction, I have no idea why they do that, to be honest, because I don't see an advantage, but some people say that the cycling does something for them, so okay, but I don't understand why and what it would do. Why going back and forth several times would do anything, but it's a practice that people do. The other thing you could do is you could fire down. If your kiln tends to cool off quickly and you want to develop some crystallization in your glazes, then you don't want the temperature to all of a sudden drop very suddenly when you turn off the kiln. So what you might want to do is turn the gas down and don't just let the kiln cool on its own, but slow down the heating rate so that you do a more slower cooling, and this will help some of the glazes to form crystals. So you're doing a controlled cooling, basically, or it's called firing down. And then in addition to this, even if you're not firing down, do you want to stay in heavy reduction while you're cooling, or do you just want the kiln to sort of cool on its own if it draws in air, let it draw in air? So you could do a reduction cooling where you leave the burners on in slight reduction. The temperature is still going to drop, but you purposely leave it in reduction to cool down, at least for the upper part of the temperature. So you have those different ending, depending on what the glazes are and how your kiln performs and so forth, but you have those options at the end. Some firing problems, the typical firing problems. Slow temperature rise. And this is where, like when you're having these problems, you sort of have to make this mental list, okay, what could it be? And almost like a process of elimination. Well, it's probably not that, couldn't be that. So how do you solve the problems? Slow temperature rise. Well, first thing is, are your burners big enough? Because when it really, as I mentioned before, when you're heating these things up, the whole idea is, am I burning enough gas fast enough to overcome the heat losses? So if my burners are not big enough, if they're simply inadequate for the kiln, I'll get to a certain point where they simply can't put out any more heat and the temperature can't get any hotter because I'm losing heat and it's pumping in heat as fast. It's like heating a screen house. I can't make it any hotter because the heat's being lost so fast. Another thing could be the atmosphere is too reducing. If the atmosphere is really reducing, I could be putting a lot of gas in there, but if I'm not burning enough of the gas, then I'm not producing enough heat, and so my temperature is not going to rise. And so if I'm trying to get to the end of the firing and my atmosphere is too reducing, I'll never get there. I'm just wasting gas. I'm partially burning it and then blowing it up the chimney. So I've probably cut my efficiency from 5% to 2%. And another thing I found also with firing, especially around like where there are group firings, is a lot of it is not paying enough attention. just not watching what's going on with the kiln and looking at, you know, like a gas kiln is something I found, at least with the ones I fired, is I can't set the controls and walk away and go have a beer or something for 10 minutes. I've got to stay there and watch the temperature and see whether the temperature is continuing to go up and watch what happens. Because again, I'm interested in keeping the firing as short and as efficient as I can for my time, as well as for saving gas. And so I don't want to have it be doing something pointless for 10 minutes while I'm off having a beer or doing something. I want to catch it right away so that I can keep it moving on this firing path. Stalling at around 2,000 degrees. When you get up to around 2,000 degrees, all kilns, all fuel-fired kilns tend to stall, which means they sort of don't want to, all of a sudden, they don't want to get any hotter. And the thing is, this is not necessarily your fault. This is a natural occurrence of physics. And this is because, as I mentioned before, as you get hotter and hotter and hotter, the heat source wants to lose heat faster and faster and faster. And so when you get up to around 2,000 degrees with most heating systems, unless you're really overpowering it with heat, it's going to start to slow down because it's starting to lose heat incredibly fast. So that's a kind of a natural occurrence that does happen. And what you have to do is you have to overpower it. You have to overpower this very high rate of heat loss that happens starting at around 2,000. So again, it goes back to burner size. Are your burners big enough for now where I can really put the pedal to the metal and get enough burning to overcome it? Am I burning enough gas? That's what it really comes down to. Am I burning enough gas efficiently to produce enough heat to keep the temperature going up? Poor or uneven reduction on pots. This could be something, I mean, you know, you at the end of the firing, you unload the kiln and you look at your pots and you don't have good reduction, or you have uneven reduction in different parts of the kiln. First thing to look at is your stacking, is how did you stack the kiln? Because it's gas and because we're trying to make sure that I get efficient mixing of the gas and the air, in different parts of the kiln, if the gas and the air are mixed differently, I'm going to get different results. So I can't assume that I've just got this uniform gas coming in. I've got to keep in mind that in one part of the kiln, the gas and the air may not have mixed well enough as they did in another part of the kiln. So that's going to give me different reduction effects. So I have to keep that in mind. So the stacking, if I know that happens, the stacking and how I arrange the pots can have a big influence. Early reduction, as I mentioned before, is really important. If you don't do reduction early enough, if you started at like 06, in a lot of cases, that's too late. Because the things have already started to seal off or close up, and the gases can't adequately penetrate the clay and the glaze, and you won't get good color. You need to maintain reduction. After you do your early reduction in the firing, you can't go back into oxidation to do the whole rest of the firing, or you'll lose, before the glazes have completely melted, you'll lose a lot of the early reduction. So you have to maintain reduction. You do your body reduction, and then you maintain some reducing atmosphere all the way up to the end. And also then, the other thing is leaks or oxidation. I've been in a couple of studios where the kilns didn't seal up tightly at the end, and so and they had big chimneys, and the dampers also didn't seal. So when the kiln was shut off, it was sucking in air, and there'd be like jets of air that would come in and hit certain pots. And so like there were certain places where you knew the pot was going to get reoxidized because there'd be a jet of air being sucked in as the kiln cooled down and landing right on the hot pot. So that's possible. Is leaks in the kiln, is the kiln tight enough that you don't have air being sucked in during the cool down. Failure to reach temperature, and as I say, it's really basic, is you're not burning enough gas fast enough for a variety of reasons. Now, it could be the burner size, it could be the gas flow, it could be the chimney height, but the bottom line is you're not burning enough gas fast enough if you're not getting to temperature. Poor copper reds. This specific category of glazes known as copper reds. If you're not getting good red color, part of it is you need, as I mentioned, you need very heavy early reduction. And it has to be early enough, and it has to be heavy enough, and it has to be sustained to change the form of the copper that's going to give you the color later on. And the other thing with copper reds, nothing to do with the kiln, they generally need to be applied thicker than you do your other glazes, because the copper can actually be cooked right out of the glaze. And so you've got, generally with copper reds, you end up with a layer of clear glaze on the top where there is no copper. You don't see it, but the copper has been lost. So if the glaze is too thin, you can just literally cook all the copper out of the glaze and there's nothing left to change color. So most copper red glazes have to be applied thicker than other glazes. The other problem is, along with that though, is when you make them, also a lot of copper red glazes tend to be a little runny. So that when you make them thicker so that you get the copper red color, then you tend to get more running. And you have to allow for that. You get poor carbon trapping. This is especially, this category of glazes called Shino glazes, and there's a subcategory called carbon trapping Shinos, where you want to get this black deposit of soot that actually gets trapped in the glaze. And in order to do that, you need really heavy early reduction, and that's where you're going to play with the air control on the burner, where you actually change the setting of the burner and make the burner very inefficient, so inefficient that it makes soot. And it's the soot that you're actually physically trapping in the glaze to make the carbon trapping. So you need to actually make soot early on in the firing, and you need to maintain reduction again so that you don't burn out that soot, because the soot is just carbon, and before it gets a chance to get completely trapped in the glaze, if the reduction isn't heavy enough, you'll burn it right back out again. So you might have trapped it, and then you burn it out and it goes away. And you also generally need to be glazes that are a little on the thicker side so that, again, you won't burn the carbon out of the glaze. And finally, high gas usage. You might find at the end of the firing, like, wow, I used a lot of gas, a lot more than I thought I would. And that could be the kiln design. It might not be very efficient. It could be even something like the insulation on the kiln. If the kiln is really is inefficient, even more inefficient and not well insulated, then yeah, you're going to burn a lot of gas because the kiln is losing heat even more. And part of it also is gas control, is controlling the gas. As I mentioned, it's possible to put too much gas into the kiln, and if it's not burning efficiently, you're wasting the gas, but you're not getting the heat out of it. So you end up with the firing where you've gone, and maybe it was a successful firing, but you seem like you've used a lot of gas to get there because you might not have used the gas efficiently. Just a couple of wrap-up comments here. Why fire with gas compared to other things? Well, it's clean, relatively clean. It's convenient because all you're doing, you're not stoking every 5 or 10 minutes. All you're doing is opening a valve occasionally. It's generally safe. The only problem I've ever seen with gas, as I say, is this early point. If the flame happens to go out early in the firing and you try to relight it too soon, but other than that, I don't know whether you remember the movie Animal House, where Fawn Lebowitz was killed by a gas explosion. I was going to donate a kiln. I was going to dedicate a kiln sometime to Fawn Lebowitz in her memory, but that was in Animal House. Belushi goes to the college and he pretends to date the woman who's been killed by the gas explosion in the Pottery Kiln. So I was going to donate a kiln sometime to Fawn Lebowitz, the memory of Fawn Lebowitz. Anyway, and gas kilns are certainly less labor intensive than wood during the firing. You can get faster heating rate as possible. I mean, if you put in enough gas, you have a big enough burner or burners, you can crank up a kiln really fast. So you can get, unlike wood, where there are certain limitations, you can get a kiln to heat up really fast with gas. You can do relatively short firings if you want to, because again, you can sort of overpower the kiln if your burners are big enough. Gas kilns are good with glazes. You don't have to worry about, and there's no ash accumulating, so you're not worried about ash or cinders or anything accumulating on glazes. You have good temperature and atmosphere control, generally better than you do with a wood kiln in terms of controlling more the temperature and the atmosphere precisely. Small kilns are practical. Really, really small wood kilns are really not very efficient because wood inherently tends to have a long flame, and so to capture the flame and use the wood efficiently, you tend to leave some kind of a kiln design that will accommodate the long flame. Well, gas burners, you don't have as long a flame, so it's easier to keep the flame in the kiln. So you can make smaller kilns. And finally, you don't need a crew to fire a gas kiln, even a big gas kiln. Disadvantages of gas. Gas is expensive. It can be expensive. I mean, right now propane, the last time we bought it was like $3.50 to $4 a gallon, which is not cheap. You don't generally do long firings for special effects. Like with wood, you might do a long firing to get additional ash accumulation or melt the ash. You're generally not doing those kind of things with gas firings. You're generally just maturing glazes. So you don't need, you're not doing them. And along with that is, I think, in a little way, there's a little less opportunity for some serendipity with gas than there is with wood. Because you've got the other factors with wood where you've got ash accumulation and ash melting, and you've got some temperature variation, I think there may be a little more opportunity for some happy accidents to happen. And that way maybe gas is a little more predictable. It's more controllable, but maybe also a little more predictable. Some general points to remember is that stacking, just like with wood, well, with any kind of firing, stacking is important to direct the flame path, because now instead of having a wood burning wood path, I've got gas flame, and so my stacking is still going to control where the flame tends to go. I need good mix, these are kind of reminder points. I need good mixing of the air and the gas ideally before it reaches the weir, before it gets to it. Unless I'm carbon trapping, I don't want to make soot. Okay, if I'm firing a gas kiln and I'm making a lot of soot, I'm operating it really inefficiently, unless I happen to be doing that one special period where I'm trying to produce carbon trapping glazes. So in terms of control, as I mentioned a couple of times before, I really want to control the balance between reduction and temperature rise, and that's kind of a delicate balance. How do I have enough gas burning that the temperature is still going up, but not so much burning that I'm in oxidation? I want to get reduction, and that's the trick to firing a gas kiln, is maintaining the balance between keeping the temperature going, but still having it in reduction to maintain the effect that I want on the clay and the glazes. As I mentioned before, a good rule of thumb is don't make more than one change of the controls at a time. Whatever you think, I mean, you got a lot of knobs here you can change, but whatever you're doing, make one change and then wait and see the effect of it. And if it helps solve the problem that you think you have, good. If not, put it back where it was and then make another change and then wait and see what happens. Don't change 3 or 4 things at once. You'll never figure it out. As I mentioned also, I monitor the heat rise by looking at the pyrometer, but I fire by means of the cones. To me, you don't fire by temperature with ceramics anyway. You shouldn't. You should fire by cones, whether it's electric or gas or wood or anything. So I'm using the pyrometer just to watch the progress of the firing to tell me how am I doing with the control. And then when I start getting close, I don't even care about that anymore. I start looking at my cones, because that's how I'm firing my work. And the last thing is get to know your kiln. If it's a kiln that you have the opportunity to fire regularly, whether it's your kiln or somebody else's kiln, is get to know it, which means get to know, are there hot and cold spots? Are there areas where the reduction is better or worse? And then load the kiln accordingly. Load glazes accordingly. I know in this little gas kiln out here, we tend not to get the best reduction at the bottom, so I'll put glazes at the bottom that don't need as heavy reduction, like some of the tomato red ohatakaki glazes, or glazes that could take even mild oxidation. So I know I've got the kiln optimized about as well as I can, and then I'll load glazes according to what I know how the kiln performs. Thank you. Oh, and I mentioned some of you came in a little after I'd started. This is sort of the 3-part series I've been doing on kilns. So the first one was wood, this is gas. Next time it's going to be electric. And then after that, I'm going to talk a little bit about general firing problems. So it'll be an overview of problems with firing. So it'll be problems that occur with firing the kiln, and then which one of those problems don't affect the wear and which one of them do affect the wear. Because sometimes you can be firing a kiln like a gas kiln, and like your temperature isn't rising fast enough. That won't necessarily hurt the work at all. It'll just use more gas and take up some of your time, but it's still a problem in terms of that you've got to get through to solve the firing, but it won't necessarily affect the wear. So we'll do sort of an overview of pottery firing problems problems with the kiln that affect how you fire the kiln, and then those problems that show up in the work. That'll be kind of sort of a summary. So next month will be electric, and then after that we'll do this firing problems summary.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.